Preface. The notion of a fuzzy subset of a set is due to Lotfi-Zadeh. His seminal paper in 1965 has opened up new insights and applications in a wide range of scientific fields. Asriel Rosenfeld used the notion of a fuzzy subset to set down cornerstone papers in several areas of mathematics, among other disciplines. Rosenfeld is the father of fuzzy abstract algebra. This book is the first to be devoted entirely to fuzzy abstract algebra. The purpose of this book is to give an up-to-date version of fuzzy commutative algebra. We present a fuzzy ideal theory of commutative rings and apply our results to the solution of fuzzy intersection equations. This treatment includes all the work that has been done on algebraic L varieties. The book includes all the important work that has been done on L subspaces of a vector space and on L subfields of a field. We focus our attention on the connection between L subgroups of a group and L subfields of a field. This connection is made in two ways. We present a Galois theory, both finite and infinite, which in the finite case gives a one-to-one inclusion reversing correspondence between finite-valued L subgroups of the group of automorphisms of a normal field extension and its L subfields.
In the infinite case, we give a Galois correspondence between L subgroups whose level sets are closed in the Kroll topology of the group of automorphisms of a splitting field of a set of separable polynomials over a field. Our second focal point is the connection between L subgroups of an abelian group and L subfields of a field constructed by means of a group algebra. We do not give a complete treatise on L subgroups. Rather, we present results on L subgroups which are of interest to the connections discussed above.
In Chapter 1, we present the important work of Tom Head and Arthur Weinberger concerning methods for deriving fuzzy theorems from crisp versions and embedding lattices of fuzzy algebras into lattices of crisp subalgebras. Other than that, we present only material that is needed for the development of the remainder of the book and that may be useful for the further development of fuzzy Galois theory and fuzzy group subalgebras. Since the work of Weinberger is somewhat outside the confines of fuzzy commutative algebra, we only present a summary of it. Essentially, only those results concerning L subgroups of abelian groups which are needed in the development of group L subalgebras are presented in Chapter 2. In Chapter 3, we give some basic concepts and properties of L ideals of a commutative ring with identity. These concepts include those of prime L ideals, primary L ideals, and various radicals of L ideals. Many authors contributed to the development of L ideal theory. Consequently, we will not attempt to mention them here. Our bibliography lists those who were responsible for the development.
The concepts of quotient L submodules, free L submodules, residual quotients, and primary L ideals are given in Chapter 4. We do not give a complete treatment of L submodules, but we do give an extensive bibliography on L submodules. However, we stop short of including papers which fall into the realm of category theory. Chapter 5 deals with L subfields and L field extensions. Concepts such as separability and inseparability for L field extensions are developed. We introduce a concept for L field extensions which is not present in ordinary field extensions, namely that of neutral L field extensions.
In Chapter 6, we delve deeper into the realm of L subrings. We present a primary representation theory for L ideals, which is used in the next chapter to examine fuzzy intersection equations. Other topics in this chapter include the L prime spectrum of a ring, quasi-local L subrings, and L coefficient fields. The results of this chapter are mostly those of the authors. In Chapter 7, we give a complete account of algebraic L varieties and fuzzy intersection equations. This material is entirely that of the authors. We also examine fuzzy intersection equations locally. In Chapter 8, we give an axiomatic approach to the concept of the generation of L algebraic substructures. We determine the generating properties, which yield the underpinnings for the existence of free generating sets and the uniqueness of their cardinalities for L algebraic substructures. These L substructures include concepts of L subspaces of vector spaces, relative P bases for L subfields, transcendent spaces for L subfields, and L subgroups in terms of P bases and torsion-free bases. Many authors contributed to the development of L subspaces. They are included in our bibliography. We do not include in the bibliography papers dealing with topological vector spaces.
In Chapter 9, we make a connection between L subgroups and L subfields in two ways. First, we make the connection by means of Galois theory, and then by means of group algebras. Here also, the work is entirely that of the authors. We assume that the reader is familiar with the basic results and definitions from abstract algebra and lattice theory.
The authors are grateful to the staffs of world scientific publishers, especially Sen Hu and S.H. Gann. We are indebted to Professor Michael Protera, Dean, Creighton College of Arts and Sciences, and to Dr. and Mrs. George Haddix for their support of our work. We benefited from the work of Professor Yu Yandong during his visit. We also wish to thank Professor Paul Wang of Duke University for his support of fuzzy mathematics. The first author dedicates the book to his grandchildren, John, Mary Pat, Michael, Christine Marie, Matthew, Mark, and Jack. The second author dedicates the book to his daughter, Shelley Malik, who is a joy, and her smile is what counts. John N. Mordison, D.S. Malik.